Okay, so this is going to be a quick guide on how to read architectural drawings. We're going to start off by discussing that all architectural drawings are scaled drawings and what that means. So to start, I have this image here of a basketball court. And let's say this basketball court is 100 feet. And let's say that this little piece of paper or this rectangle represents a sheet of paper, an 11 by 17. So if I was trying to say to someone else to build me this basketball court, but all I could do is hand them this piece of paper, I would use a scaled drawing. And so what that means, so let's say the basketball court is 100 feet. And so on this piece of paper, I'm going to say 1 inch equals 1 foot. Meaning if there's 1 inch, which is what? Tiny? That represents an entire foot. And so this 100-foot basketball court on a piece of paper is only 10 inches wide. So all architectural drawings are scaled drawings. Some common scales are these ones. 1/4 inch equals a foot, 1/8 of an inch equals a foot, 1/2 inch equals a foot, 1.5 inches equals a foot, and 3 inches equals a foot. Got an extra little apostrophe there. So that's why you see these big, large pieces of paper where the plans are on, because we have a 200-foot building at 1/4 inch equals a foot. That now becomes fairly good size. It's not going to fit on a 8.5 by 11. Okay, now that's not the only tool that we have as architects. So here I have a 3D house, right? So we build it all on the computer. Here it is. There are, let's see here, 1, 2, 3, 4, 5, 6 different kind of views or tools that we use to communicate to other people. This is how you build this building. So we have this digital model, and then let's say, so the first one's going to be plan view. And what a plan view is let's say we cut this first level, and then we cut the house about 4 feet off the ground, and then we take the camera and we put it directly on top. This is a floor plan view. So this might look familiar if you look at it like this. Something you often see, right? And so plan views are any views that you're looking from the top down. So it could be a site plan, a roof plan, a floor plan, any type of plan. Okay, another view that we use, let's change this back to realistic. Oh, it wasn't realistic. Oh gosh, hopefully my computer doesn't crash. It's an old computer. Another view is elevations. So when this stops, okay, let's change it back. Consistent colors. So an elevation view, all that is if you put a camera directly in front of the building. So this is an elevation view. You have the front elevation. Let's orbit around here. We put the camera view. Whoop. Side elevation. Here. Rear elevation. Simple enough. So this is another thing to communicate a different view on architectural drawings. The next one is a section. So all this is let's say you took this house, and let's say we wanted to cut right where that fireplace is. So same thing as an elevation, you change the camera to be like 90 degrees from what you're looking at, but now we cut it in half. Boom. This is a section view. And you can have this, which is a building section, which is the whole building cut, or it could sometimes be just a small portion, which is a wall section. But this is a section view. Then you have details. So detail can be anything, looking down, looking up, really anything. But what a detail is something really, really, really close up. So let's say, I know this isn't drawn this way, but let's say I have like a footing detail. What that view would look like is like this. It's not showing anything else of the house. You can see here in 3D view that it's that part of the foundation wall. And then you just cut it, zoom into it, and then you're just detailing out little pieces and parts that you see in this view. That's a detail view. And the last thing is schedules, which we'll just jump into an example. Let's see here. Oh, I gotta find it. Just give me a second here. So schedules. So this is an example project that I pulled up. Schedules, all it is that, let's say you have a floor plan view. This is a floor plan view. So as you can see, it's just the building. It's getting cut about 4 feet off the ground. And then you have little tags. So if I go to the doors, which doors on plan view look like this, it's the door panel, and then it's showing the arc of the door swing. And it says 106A. Schedules, you would go to the door schedule, you look for 106A, and there it is. It's a 3'7" door. Thickness is 1.75 inches. It's stained, and then other information. It's a rated door, for example. So all schedules is just clumps of information which is referenced from other views, whatever views those could be. But often you'll have a door schedule, a window schedule, a frame schedule, hardware schedule, different kinds of schedules. So now let's go through floor plan view and look at some of the symbols. So this is an example sheet, and what you see here is you have project information on the right side. Oftentimes it's going to be set up this way. You have your north arrow, a little legend, and then you have your sheet number, title of the sheet, and then project information, which I've redacted because it's just an example set that I had. Then you have your general notes, and then you have some different symbols. So this looks complicated, but it really isn't. It's just layers of information. And so first you have your grids, which grids are typically used for structural. They're used for foundation walls, columns, and it's just to set up the bones of, the building. But then you also have here dimensions. And so the hyphen or the one apostrophe is feet, and the quotation mark is inches. So 23 feet, 0 inches, for example. And so you have dimensions, you have your doors, you have your windows, you have your door tags, which is this one, your window tags, which is this one, which would reference you back to schedules and give you more information on what those look like. And then you also have call-out views. So for example, this guy, because it's cutting, there's a line there, it's a section view. And it's number 3 on the sheet, and the sheet is AA302. So I don't have that sheet here, but you would go to AA302, and then number 3 on that sheet is that section. Some other little symbols that we have. These little clouds, those are deltas. You don't typically see those in floor plans, especially in house floor plans. That's more commercial. And what it is that part of the drawings have been revised, and this is clouded and tagged with the little delta, which is this triangle, to show to either city officials or contractors, this is what has changed from the previous edition release. Let's see if we can find another call out. So these are sections. Here's an elevation. So it's view number 4, and I would go to sheet AA201. Now, really quick with the numbers. So typically per CAD standards, there is some reasoning to the sheets. So typically it starts with the letter to show the discipline, because there's different disciplines. Right now I'm going through architectural, but you also have general, which is G, civil, structural, mechanical, electrical, plumbing, maybe even landscaping. And sometimes you have others too. Like I had one project where there was a kitchen consultant, and so we made that one K, for example. But then you have the second number, or like the first number of the 3, which is the type. Per CAD standards, 1 is plan views, 2 is elevation views, 3 is sections, 4, I forget, 500, I believe, I forget too. 600 is for sure schedules. But The reason why I do forget actually is because different firms don't necessarily use that. I've been in a lot of different firms, and everyone kind of personalizes that. But there is a CAD standard, and so I'm very used to. I don't think anyone doesn't use one as not plan. It's always plan view so far. And then the other number is just the sequence. So A101, is floor plan. Let's say there's a second level, it could be A102. So they're both plan views. One is the first level, the other is the second level. So in essence, that's it. Although there are some variations, like for example, you have a reflected ceiling plan, which I don't have an example of, which is a plan view, but instead of looking down, you're looking up. In reality, it's looking at a mirror as if it were on the ground that is reflecting up. But anyway, okay, so let's keep going. Some examples. So this is an elevation view. So if you remember from the 3D house, it's just a camera directly in front, and this view, you're going to be getting a lot of materials. You're going to get building heights, where the windows are kind of situated on the wall. But for the most part, I'd say elevations, it's for materials. So you kind of see kind of similar things. You have a ground plane in this one because it's cutting, or it's looking at it from the side, but you have your grids still. And then you have some section views. So number 4 on sheet AA302. 3 being that it's a section. And then you have your notes, and then it's about the same information. This is a new symbol. It's a level, and what these are to indicate where that is reference to the ground. And then these little guys are keyed notes, meaning if there is here, so this number 1 is a keyed note referencing to this little guy here, saying that it's TPO, membrane roof, C specifications. So it's just indicating that. So a lot of the times in these elevations, they'll keynote a lot of these different elements, because in reality, like I don't know what, this is representing. And so the keynote says, okay, go look at 4A. So I go over here, go to 4A. Apparently that's a water managed EFIS system, white with score lines. Okay, good to know. Okay. And then here, an interesting little stair. Okay. So as I'm looking at it, one thing to note, here's the view name. So the top is the view name. This is the scale that it's at. And then this is the number on the sheet. So this one is number 1 on this sheet, number 2, number 3. And they're all at 1/8 of an inch equals 1 foot. Okay? Let's move on to sections. So if you remember sections, all it is cutting the building, and then you're looking at it directly on. Here, you're going to see a lot more like elements like structure. You see here that they had drawn the trusses and the floor assemblies. This is a indication of insulation, this kind of loopy thing. So you're going to see that often. This looks like it's CMU. You can see in the black, and CMU is concrete masonry unit, or cinder block. Some of you might know it as. And then you have your footings and your foundation walls. And this one, it has something unique. It's a call out. So the other views, like this one, is a section. This one is similar, but it's using a rectangular line to indicate, okay, on sheet AA420, number 5 on that sheet, you can get a bigger close-up of this stair section. And so it's essentially still the same thing. It's probably just at a slightly bigger scale and more information, probably dimensions, keynotes, other stuff like that. Okay, last thing, details. So if we go to this section, let's see if we can find a detail on this one. Oftentimes, it looks like they're calling them out on their wall sections, which I don't have. So oftentimes details will either look like this. Actually, this is a detail view. So this is a section, has a little triangle. this is a detail call out. So AA501 number 3, and it looks like it's detailing the roof assembly because this is the roof. So if I go to detail sheet, do I have this one? No, it's not this one. Okay, but for example, let's look at this one, might make sense. So this is the roof drain, and so it's showing the assemblies, insulation, the pipes, and then the roof drains themselves. And then it's calling out different information, and it's showing how you would flash it to prevent leaking. So for example, this top line, which is in the dashed line, that's the membrane, the roof membrane, and they have it drawn, and then it's supposed to go over the drain bottom, and so that the water comes down, goes through, and right into the drain. Versus if the membrane went under, the water would want to go under. So that's the perfect purpose of details, is to create those types of instructions for when they're installing it on site. It's very clear, how to assemble that. Now, a lot of times, a lot of contractors complain about architectural details because they're not realistic, and a lot of us don't have a lot of experience constructing these things. But we do our best to have our design intent and cover our butts if something goes wrong. So yes, detail views, similar condition. Oftentimes they're 1.5 inches equals 1 foot, which means it's just really zoomed in. So this is probably, let's see if it calls out what is the size of this. It doesn't, so it'd be probably in structural, but this is probably like a 14-inch wood eye joist. And so 14 inches, but here it's probably really small, just so that we can see how that's assembled. So those are detail views. So in essence, that's essentially it. Architectural drawings, all they are is just a series of different views with different information layered on top of them. They look complicated, but in reality, they're not. Once you start getting familiar with them and understand these principles, you can read any set. So thank you so much for watching. Thanks.